This is an example of how to differentiate from first principles using the function notation. Our definition for f dashed of x is the limit of f of x plus h minus f of x all over h. And as we take that limit when h becomes smaller and smaller and smaller, this will give us eventually the gradient of the tangent, which is our desired f dashed of x or dy dx. The other method of doing this is using delta y's and delta x's, and that method's been around a long time obviously, but this method really is preferable once this function becomes nasty. If you've got cubes or 1 over x squared terms and so on, I think this method is far more accessible. So what I have to do now is to rewrite the formula and put in the function evaluated at x plus h. Now this is the function evaluated at x, so I replace each of these x's by x plus h. So what I've basically got here is 2 lots of x plus h squared minus 3 lots of x plus h, and then I take away the f of x, which is the function I started with, and all of that is divided by h. Now I have to expand this squared bracket, and one must be careful here because everything must be times 2, and it's quite easy for signs to go awry if you do it too quickly at this stage. So what I've got here now is the limit as h tends to 0 of 2 times the square of that bracket. Now the bracket squared is x squared plus 2xh plus h squared. So when I double up that, I get 2 lots of x squared, 2 lots of 2xh, and 2 lots of h squared. And I'm taking away 3x, I'm taking away 3h, I'm also taking away 2x squared, and finally I'm adding on 3x. This is where the minuses can become a bit of a problem. Take it step by step, you shouldn't have a problem. Now this is where things start to cancel. 2x squared minus 2x squared, and you've got minus 3x and plus 3x. So all of this reduces down now to the limit as h tends to 0 of 4xh, the 2x squareds have gone, plus 2h squared, minus 3x or plus 3x go, minus 3h. And all of that is divided by h. So I perform that division, and that leaves me with 4x plus 2h minus 3. Now as I take the limit of this as h tends to 0, I end up with 4x minus 3 as the 2h just disappears. So my final answer is 4x minus 3. Now this method is not difficult, but you have to pay attention at key points during this proof. Practice it yourself, because as you already know the answer by applying the formula, doing it from first principles means that you do know whether it's working out or not. And it's well worth playing around with some of these, but start with quadratics, and you needn't really go beyond that unless you're studying further pure.